Hi, everyone. Here's the graph of y equals 1 over x minus 2, by the way. It should be a familiar friend, right? It has a VA at x equals 2, as we've said. This is the graph of both y equals this over here and y equals this over here. These are equivalent expressions, perfectly equivalent. If you graph y equals 1 over x minus 2 on Desmos, we see we have a VA at x equals 2. This blue line, it should be dashed. Right? It's a horizontal translation of our classic y equals 1 over x. All right, so if you have y equals a rational expression like this, polynomial over polynomial, if it's not simplified, what's the deal? So if this thing here is not simplified, then the real zeros of the denominator can correspond to VAs or wholes. And to figure out which you're going to get, it helps to do things like factor and cancel. You have a VA if the problem factor still survives in the bottom. If x equals, okay, if you have a question about x equals 2, the problem factor is x minus 2. If you have a question about x minus 3, the factor is x minus 3. Okay, so now, oh, by the way, more about this graph. Also notice there's an HA. Where? At the x-axis, because that's bottom heavy, y equals 0. We should indicate the horizontal asymptote as well. Again, the purple HA should be dashed. In the long run, it looks like a cross. If you zoom out, it looks like a cross, the HA and the VA. All right, so here's an overview. Comments on graphing rational functions. Assume we have y as a function of x. Y equals f of x. Well, first of all, the biggest issue is to determine the domain of f. All right, so if you have something like y equals 1 over x squared plus 1, that was this bell shape over here. Domain was all real numbers, and we had no VAs or wholes or anything like that. Every real value of x corresponded to a point. The domain was all real numbers. But if you do something like remove the plus 1 from the denominator, look what happens. Our dormant volcano explodes, and we have a VA at x equals 0, which corresponds to the real 0 of the denominator. Before, with 1 over x squared plus 1, there were no real zeros for that bottom guy, so we never had a domain problem, and we had no VAs or wholes. So that plus 1 down there made all the difference in the world. Find any VAs, HAs, and wholes. Now bear in mind that VAs and wholes are related because you have to wonder if you have to simplify the expression. All right? Simplify the expression to see what's going on. All right. HAs and SAs are actually more related. HAs and SAs, again, deal with long-run behaviors. I made these comments up here. Remember, VAs correspond to sudden explosions versus, these are very different, HAs and SAs deal with long-run behavior. VAs care about simplification. HAs and SAs do not. So they don't care so much about factoring and all that. Okay. Remember that graphs of rational functions, like polynomials, they don't have cusps or sharp corners, such as the absolute value graph. In between VAs and wholes, they kind of look like polynomials. In between VAs and wholes. They kind of look like polynomials. Okay, find intercepts. Remember the y-intercept, if any, tends to be easier. If 0 is not in the domain, then there is no y-intercept. Right? But if there is, the y-intercept is easier to find. X-intercepts tend to be harder because you have to solve an equation usually. Solve the equation f of x or y equals 0. So it's usually harder to find x-intercepts. By the way, you might have none, one, or a whole bunch. Even odd, you may be able to exploit symmetry. And another trick that also works with polynomials, long-run behaviors, the zoom out property. In particular, if the degree of the numerator is less than the degree of the denominator, okay, then you have an HA at y equals 0. In fact, as long as it's not top-heavy, you have an HA period, okay? As long as it's not top-heavy in degree, you have an HA. But if you have the top-heavy case, where the degree of the numerator is greater than the degree of the denominator, then you do the long division, and in the long run, you get like a bull or a snake. Maybe a slanted line, in which case you have a slant asymptote. That's if you're top-heavy by 1 in degree. Okay, but in the long run, I've said this before, a rational graph will look like a line, a bull, or a snake in the long run, if you really, really zoom out, like a polynomial. A rational graph will look like a polynomial in the long run, if you zoom out. Where can a rational function change signs? Where can you go from being above the x-axis to being below, or vice versa? Well, like with polynomials, it could be at an x-intercept or at a real 0. Okay. But now with rational graphs, you may also have an issue with a VA or with a hole that might happen to be on the x-axis. By the way, a hole on the x-axis does not count as an x-intercept.